Hello and welcome. Today we're going to be looking at polynomial factors and graphs as part of the Passport to Advanced Mathematics section. As always, we're going to be looking through 5 questions and we're going to be explaining them and looking at the intricacies of this topic to help you ace the SAT math portion. If you like these videos or found them informative, please be sure to like and subscribe. And with that, let's get started. Question number 1, the polynomial function f is defined as f of c equals c minus k times c squared minus 4c plus 4, where k is a constant. The value 2 is a 0 of f. What is the remainder of fc when divided by c minus 2? All right, so there is this thing called the remainder theorem, right? The remainder theorem is very critical here, and this is what it basically says, right? So if you have, say, a variable, right? So c in this case, c minus a constant, which I cannot put c minus c. So what's a constant? We can say the constant a. So when you divide f of c divided by c of a, the remainder is going to be f of a. So when I just plug in a into the function. So the remainder of c minus 2 is going to be f of 2. But we're told that the value of 2 is a 0 of f, which means that when you put f of 2 is just 0, which means that the remainder is 0, and it's a clean factor, right? So it goes in nicely, and the remainder is 0. And this is something special that we call the factor theorem. All right, the factor theorem essentially states that if you plug in a number into that f of c, and it makes f of c equal to 0, then that c minus that constant that you plugged in is going to be a factor of f of c. It's going to be a clean factor with no remainder, right? So these two theorems, the remainder theorem and the factor theorem, are critical when we're dealing with polynomials because they simplify things a whole lot. Like, yes, you could probably have figured this one out if you didn't know this. It would also take about 5 more minutes, which is time you don't really have on the SAT, right? So using these two theorems, the factor theorem and the remainder theorem, make your life a whole lot easier if you just remember that when you're dividing by c minus a or x minus a, the value of the remainder is f of a. And if f of a equals 0, then you've got yourself a divisor of the function. That's it. Let's move on to the next question. All right, polynomial function f is defined as f of m equals m cubed minus m squared minus 17m minus 15 times m plus 1. When f of m is divided by m plus 1, what is the remainder? Well, it might seem a bit obvious here that if we divide by m plus 1, you're just going to cancel this one out with this one, and you end up with no remainder because you still have a full factor there, right? So the remainder is going to be 0, obviously. But for the sake of argument, we can still use the remainder and the factor theorem because they will not always be that kind to like actually factor it for you. So m plus 1, that's going to be m minus negative 1. So the remainder, when you're dividing by this, is just going to be the same as f of negative 1. Right, so f of negative 1 is what? Well, that's going to be negative 1 minus another 1 plus 17 minus 15, which is already 0. So we don't even need the other factor. But that's already 0. And then this is also a negative 1 plus 1. So it's just 0 times 0, which is equal to 0, which means that the remainder is just going to be 0, as we've seen. And that's how you use both the remainder and the factor theorems effectively. The remainder is 0. And let's keep going. All right, here we have L of x equals x to the 4th plus 36x squared minus 10,000. Polynomial function L is defined above, and we're asked for the remainder of L of x when divided by x plus 10. Well, let's see what we can do. So x plus 10 is x minus negative 10. So the remainder here is just going to be L of negative 10. What is L of negative 10? Well, negative 10 to the 4th power is going to be 10,000 plus the 36x squared, which is 3,600, minus the 10,000. So these two are going to cancel out. And our answer is just going to be 3,600 as the remainder. Right, simple as that. We didn't need to divide, we didn't do long division. We just plugged in a number, we figured it out, and our answer is 3,600. Let's move on. All right, next question. G of w equals w plus 13 to the third power times w plus 19 squared. The polynomial function g is defined above, and when g of w is divided by w plus 16, the remainder is r. What is the absolute value of r? Well, let's see what we can do here. W plus 16 is w minus negative 16, so we're just going to find g of negative 16 using the remainder theorem. So we plug in negative 16 in here, so negative 16 plus 13 is going to be negative 3 to the cubed is negative 27. And then negative 16 plus 19 is 3 squared is 9, so negative 27 times 9, which is negative 243, right? Which you do have, this is calculator active, so you can use the calculator, you don't have to do it all in your head. Then you're asking for the absolute value, so the answer is going to be 243. And that is our answer. Again, simple as that. No extra calculations required if you know these two critical theorems. It's not even that much to remember. And here we are. A function p is defined as p of x equals x minus a times x minus 15 times x minus 20 plus 15, where a is a constant. Given that p of 7 equals 15, what is the value of a? Okay, so p of 7 is 15. All right, so this is interesting, right? So we plug in p of 7, so we get 7 minus a times 7 minus 15 times 7 minus 20 plus 15. And this is supposed to equal 15, which means that this whole part right here is supposed to equal 0. Now, this part is not 0, and this part is not 0, but one of the factors has to be 0. So 7 minus a has to be 0, and a equals 7. That wasn't the remainder theorem, but the factor theorem. As much it was just a clever manipulation of the algebraic equation, but it still works, and our answer for A is 7. And we are done with this set. As you've seen, the critical skills when dealing with polynomials like this, we just plug in values into the function. We use the remainder and factor theorems, where the remainder is just the value of a plugged in to the function when you're dealing with x minus a. Remember that if you have something like x plus a, then you have to plug in a negative a to get it to work. Remember that the factor theorem happens when you plug in your a value and it gets 0, then you have a clean factor. And remember that you can always apply these in any polynomial, and remember to be able to manipulate these functions in any way you choose to get what you want. That's it for this, and I'll see you next time.